Okay, seems you're live. Hi, hello everyone. Vanakkam, good morning, good afternoon, good evening to whichever part of the world you're joining from. I'm Mudit. I'm from the team of DeFi. For those who don't know, we are a data science platform, a data science community rather, a place where anyone can learn data science, data engineering, ML ops for absolutely free, and they can help each other in the process. Now, I believe more and more people will be joining in. So I think we can wait for a couple of minutes. If you can hear me, just probably drop a hi comment or something. Okay, can see comments on YouTube. Not sure if you can see comments from LinkedIn right away. But yeah, so hi everyone. By the way, Edwin is also with us at the moment. I'll also be adding him shortly. But I think we can wait for a couple of minutes, and then we'll get started. Okay, I think people have started commenting. Hi everyone. Hi Kimia, hi Iobosa, Yus, Ibrahim, Ame, and a lot more. Okay, nice. Good to see you. Good to meet everyone here. I'm not sure how many of you are here for the first time. I could see there. So we got a phenomenal set of people registering for this particular session. We had over 600 people who registered for this particular session and shared their questions with us. So I think we'll wait for one more minute and we'll get started after that. We'll start in 1 minute. Yeah. Hi, Brock. Hi, Aditya. Good to see you here. Hey, Aziz. Hi. Hi, Kiran. Hi. How are you? So, okay, great. We'll probably get started now. So, hello to everyone. We are super stoked to have you here. I'll give a quick introduction of myself. I'm Mudit. I'm Mudit. I'm one of the founding members of DeFi. We're a Belgian startup and a global data science community platform. To share a quick just about what we do. So what we are building at the crux of everything is a community where anyone can learn data science, data engineering, ML ops, and related fields for absolutely free of cost. What is the beauty of our community is that all our resources are open source. People like Dr. Edwin join us to share our passion and help others in learning in the process. So this way, whether you are a beginner in data science, absolutely getting started, or nailing it as a AI researcher or a principal data scientist at any of the global organizations, you can still join the community and start adding value and gaining value from it. So that's what we do. So we connect these live sessions. We'll be connecting them in the month of May as well. Same time, same place. Saturday in India, it will be sometime around 8 p.m. Based on your time zone, you can check out. We also have a couple of more live sessions lined up. For example, in the next one, we have Vedansh from who's a data scientist at UPL. He'll be talking about implementing AI in agriculture. Then we have someone from Microsoft Research. Then a principal data scientist talking about ML ops and much more. So do stay tuned. There's a lot of things that you can get from the community. There are a couple of boot camps also running at the moment, 7 to be precise. They start from something around Python for data science, which is an absolute beginner level boot camp, to something as maybe advanced to as explainable AI and unsupervised learning. I share these are all open source in nature, so you can join in at any time that you want to. You'll have to submit the assignments, and we'll help you get them reviewed and all. Apart from that, we also have an AI challenge ongoing. So let's say you are at an advanced stage of data science and you want to learn by implementing data science. So we keep on conducting these data sprints where you can implement and learn from it. So that's what we have built so far. There are a lot of other announcements coming up real soon. So stay tuned. I'm sure you would love the community. Now, I'll probably introduce our speaker for the day, someone who has been super kind enough and have shared their time with us. So Dr. Edwin Campos is a PhD and a data scientist. I came across his work on Google Scholar, which is when I thought of reaching out to him. And I'll probably talk about it. So he's working in a consulting role at Heitman, which is an American real estate investment firm. He works as a principal data scientist there and develops data science solutions for managing investments at the firm. Apart from that, he is also working as the meteorology head at Parachute Insurance. His work has involves around developing predictive and geospatial tools with applications in global property sector, fintech sector, renewable energy markets, sports, airlines, and many more. He's an expert in meteorology, which is where he's one of the best people that we could have invited for this particular topic. So I think we must thank Dr. Edwin for being with us today. Uh, Now I'll invite him to the session because it's his session. His session. He has prepared. He has worked hard for you all, so that you can learn around the process. Please stay tuned towards the end. There's a team working in the back end at DeFi, which will ensure that we try to pick most of the questions that you're asking. So ask any questions that you might have for us and for the speaker. We'll be answering that. So thank you so much. Over to you, Dr. Edwin.
Hello, everyone. I'm so excited to join the community, and thank you for inviting me. I hope also that you have a great Earth Day yesterday. And that's why this talk is very relevant or very opportune as well, because it joins all the learnings all the meditations and all the advertisement also that we receive about how we can help Earth. And let me share my screen so that we can see the slides. All right, so we're going to talk about how to apply the knowledge of artificial intelligence and climate risk into our businesses. It's going to be very practical, and I would appreciate if we can get a lot of your feedback as well. So as Moody says, there is a team in the back end of this presentation that are collecting your input, your feedback. So I'm going to give some motivations of why this is an area that excites me a lot, and I hope you get motivated as well. And then I have time for questions and answers, and then we go back and deep dive into one of the main hazards that I've been studying, which is tropical cyclones. Again, we get more interaction with the audience, and then some applications, particular applications of artificial intelligence and data science in our businesses. All right. So again, Earth Day yesterday, and it was great to see Google put in this doodle, and that is the evidence of how climate change is changing our societies, our environments. All right. So we have as a word of motivation, only in United States last year, if we count those expenses more than $1 billion, we get a total in damages of 145 billion in US dollars. This is 10 to the 9, right? So, and this is most of that. So we can see hurricanes are very important, but we get forest fires are becoming more important. We got floods, severe weather, right? So we have to do something about this. As we see also the trends, this is another figure from NOAA, National Oceanic and Atmospheric Administration in the United States. We can see how the disaster events are changing. In the bars correspond to the number of events, so they are becoming more common, as you see, from 980 to 2021. The lines corresponds to the cost of the total cost plus minus an uncertainty, which is in gray here. Right? So you can see that there are spikes in the time series, but as a trend, you can see that there is an increase. Right? So the conditions in which we usually compute risk are changing. Right? So we have to adapt the way we have been computing risk. So one of the tools that we have to reduce our risk or our losses is through insurance. Right? For example, company Aon, which has its headquarters here in Chicago, estimated last year that we were $343 billion in total, right? So this is way larger than what the National Oceanic Administration estimated, right? Because they are counting based on insurance claims. But there is a gap of 62%, they say. So what do they mean by this gap? So let's try to examine for a moment how an insurance policy will work, right? So you get a deductible. So let's see this plot, for example. This is how much is the loss due to a disaster, national disaster. And this is how we share the risks. Okay? So there is going to be, we have a deductible, right? If the damage is below a certain number, let's say $10,000, for example, then we have to cover that, right? We as clients of the insurer. If it is above the threshold of the deductible, then the insurance policy start to pay us, right? But they can pay us up to a certain limit. If it is devastation, what we get, for example, with a hurricane or something very, very widespread and intense, then they are not going to cover that type of limit. There are also exclusions, and more we see areas of the world that they don't insure the property due to the flood or due to hurricanes, right? The risks are so difficult to compute that the companies that insure, they decide, okay, we are not going to insure for this type of calamity, right? Also because the risk of having that event happening on a particular property is too high. It's not manageable in terms of business, so they exclude those things. So all this area in here in orange is what has not been is the gap that we say, the insurance protection gap. So we need to reduce the risk. So we need to create products that are on this area. Right. So this is one of the motivations.
Dr. Edwin, can you hear me 1 second?
Yes.
Yeah, awesome. Can you probably go to full screen, because a couple of users have asked that.
How about now?
Yeah, I think this is perfect. Thank you.
And how about now?
Yeah, great.
Awesome.
Yeah.
Good. Thank you. So let's move on. So what are the industries across the globe doing about this? Well, we hear about risk and mitigation and adaptation. We hear about climate risk disclosures, fossil fuel divestment, and ESG investments. So let's go very briefly over this, right? So risk mitigation and adaptation, right? We see some trends coming. We try to build infrastructures or properties that are going to be less exposed to those changes, those natural disasters, right? We also are going to disclose what are our risks for a particular type of event, right? And in that, there is a community called the Task Force on Climate-Related Financial Disclosures. So they have a list of things that the company should disclose, and these best practices are now being adopted by countries around the world. Right now, New Zealand and United Kingdom has to disclose, is a mandatory for the business in those countries to disclose the climate risks. Right? And in United States, there are right now laws that are being written in terms of how to do this mandatory as well. Right? It has to pass through several steps, but many other countries around the world are already ahead, implementing and creating laws that will do this mandatory. So there is a huge amount of data, and that can help us now as a data scientist or in our own business, how to reduce the risk. And also we have to have teams within our companies that are going to be working on maintaining these metrics for the company. Divestment on fossil fuel. So that was very popular even before the pandemic, right? People try to get out of the business that depend on fossil fuels, oil and natural gas. Now with the war that we have, is even more evident, especially for Europe that depends so much on what is going to happen on the war for the fossil fuels. So it makes sense to divest from fossil fuels. This is if we, for example, hold property or hold stocks that are very vulnerable to fossil fuels, we try to sell those and invest on other things. And what things do we invest on? Properties, on stock markets or all other securities that are ESG. E is for environmental, social, and governance. investments. These are three fundamentals that can be translated into metrics, right? And then data scientists or business analysts can go over those metrics, and then we can say, okay, this is something that I want to invest. Okay, next slide. So, for example, where I work at Heyman as a consultant, ESG is very important, right? So they employ environmental, social, and governance criteria, not only to manage the property. So the Heyman has over 2,400 properties and across the globe, right? And they are acquiring even more. So they have a team of researchers in real estate that try to find the best opportunities. And in total, there are $51 billion in assets that are under management, right? And the goal that they have is to go to net zero in energy by 2030. These are only 8 years, right? So the change is going very fast. And to do that, one of the things is to use the principles of ESG into the properties that they are managing, right? The clients own the properties we manage, and we help the clients. Heyman helps the clients to find the best new properties, and to find, while they are finding these new properties, they look at these metrics, ESG metrics, different variables that they see. Okay, there is high risk, low risk, and if there is high climate risk, they put the business opportunity, the property that they are considering to acquire, low in the list of priorities, and they are going to favor the ones that have low risk in climate. Right, so this is one of the things. The other one is for the properties that are already managed, you can change the way it is handled. For example, you can put sensors, a lot of sensors into the building and make it more smart, a smarter building. You can put solar panels and then generate its own energy. And this, with all these practices, having smarter buildings, having more independent buildings with renewable electricity, the goal is to have net zero in these properties, right? So other things that are coming also, when you try to see, okay, this property, for example, is very sensitive to climate and weather risks. What is going to do? What is going to happen in the community? Are they going to increase the taxes to try to pay for the damages that the weather and climate risk events are doing to the community? Insurance, what is going to happen to insurance? These are things that are very difficult to predict. So these are opportunities for the artificial intelligence community, for the data science community to start to explore it here, right? So any questions or comments? If not, feel free again to put your comments. So let me give you some examples of the things that I see as a data scientist, right? So with that, I see, okay, there is an investor, and as an investor, we want to find some tools that can help me do the investment, right? So when an investor comes, we try to put from the vision of a data scientist to put that into an agile story, agile user story. And it is simply to have identify who is going to be the user. What the user wants and why the user wants this. And this is one example. So the investor is the who. What that he wants a web service, right? And why is because he wants to factor the climate risk on a business opportunity, like the one that I was explaining with Heyman. Let's say I'm an insurance company, like Parachute, which is where I also have great collaborators. So one wants to a tool to calculate premiums, right? How the cost for the clients to pay for the insurance product. Okay, and why? Because we want to have those premiums proportionate to the weather and climate risk, right? So this another user story that I see very often. So there is a consumer, right, and we want to have metrics. For example, I want to go into the stock market of a particular country, but I want to have some sort of metrics that allow me to align my investment with my values. Let's say I'm very much into the environmental protection, right? So is there something that allow me to invest on this and divest from other stocks? For example, ESG. The ESG, these three letters, they mean a lot. in the stock market for someone like me, right? So is there any other metrics that allow me to see how the trends, how profitable can I be if I invest on this one, right? And the asks that we get from the clients are even larger. Sometimes they say, and can I have that in an app, right? Well, nowadays everything is in an app, so why not this, right? So the opportunity is tremendous these days. Challenges, of course, comes with these tremendous opportunities, right? One of these is to categorize the risk, right? And this is the common denominator of our talk today. Whenever possible, when do I want to know the risk? Is right now the risk, or is it within the 10 years? For example, if I am going to invest in a property, usually in companies like Heyman, they are going to manage the property for 10 years. And after that, there is a shift in properties, right? Everybody, the ones that want to live get the earnings, and the people that want to stay, we start again, right? So it's not necessarily 10 years. We have models that allow us to find optimal years. How much should we stay within a property, right? But this is an idea of the time horizon, right? Longer term, some things like mortgages, for example, is 30 years. So what are the risks within these 30 years from climate and weather? So it depends on the application. We have to be mindful of this term, and there are going to be different tools to calculate the risk based on that. Also, the data. A lot of the data, environmental data, comes from sensors, and each sensor is going to have its own data format that is can be binary or can be ASCII, and can be coded in different ways so that it is optimized for the transmission and storage, not for humans to read it. So you won't find very difficult to find a CSV comma separated values file out of these sensors. So the data scientists have to know how to move from something that the sensor is giving us into something that the machine learning algorithm or the Python library is going to be able to read and use. This is a big challenge because there is a huge collection of data formats. That's where one of the areas of expertise that we need in the team, right? To have somebody that is able to translate this. Imagine, for example, in the United States, the National Oceanic and Atmospheric Administration is estimating that over 210 million weather observations are processed each day to create a forecast. In places like the European Center of Meteorological Weather Forecast, which is one of the most prestigious weather forecasting centers. So they curate the data that they use, right? So they are going to have a smaller, more impactful, according to them, set of data, but it's still huge. It's 40 million observations every day. So this is what we call big data, right? It's very hard to put that into a database, into a SQL database. So we use all the other tools, and these centers provide to society those data. Very often, a lot of the data goes for free because it's being paid with our taxes. Some others have value added. And so at this point, because of all this complexity, it makes sense to focus on well, we will get more impact for our effort, right? So if we see this table also from the National Oceanic and Atmospheric Administration, this what we have is the cost from 1980 to 2021 of the natural disasters. And you can see here that the costliest of all are tropical cyclones, right? 148, 0.10 to the 9, right, in US dollars. And this is adjusted for inflation. Consumer price index adjusted. This is what the CPI means. Also, it's very costly in life, right? In deaths per year. So we have to do, if we have limited resources, let's go to the one that in which we can be more impactful. And I am arguing here that tropical cyclones is one of those, at least for United States. Each of your countries will have a table similar to that, and you can make the assessment where the business opportunities are and where the risk is larger. Okay, so I would like to talk about tropical cyclones, but before I move on, I like to go back to Moody and see if there are any questions that we can handle at this moment.
Yeah, as of now, there are no questions. I think people are, people are watching. There are over 50 people watching across various channels, but there is no question so far. So yeah, probably we can go.
Okay, good. So let's continue.
You will probably have to share using the, yeah, yeah, perfect.
Okay, good. So tropical cyclones, they are also, uh, it's important to get this into context, because in the data what we see usually is a tiny point, but there are huge systems, 119 kilometers on wind speed that you will get, but also in terms of the extent, right? You can have miles and miles and miles. Here, what we see is Hurricane Harvey in 2018 in August, right? So this is the eye center, and we usually in the data we see a tiny point in the center of the cyclone. But all this area, look at all this area. This is Texas, right? With the Gulf of Mexico, Louisiana. This is what we see here, right? So it's a huge system, right? And so the one example here is the second costliest, $125 billion, right? And if you look latitudes and longitudes to get an idea of the extent, so from you will expect the hurricanes or the tropical cyclones to be formed in a vast area, not only in here, in those areas in here, but between 5 degrees latitude and 20 degrees latitude. It's very often when we get these are systems also that rotate cyclonically. So in the northern hemisphere, they are, if you use the right hand, put it in the map, they are going to rotate like that. In the southern hemisphere, put it the other way, and they are going to rotate in this direction. So they are huge systems with rotation. And now going back to the center of the cyclone, if we track all the center of the cyclone, this is what they are going to look like. All the tracks, the best tracks. You can see concentrations, area of concentrations. So that helps us to calculate the risk of the event. Right, so you have basins. We call those basins. This is the North Atlantic Basin, the Pacific, on the East Pacific, Northeast Pacific. We have another basin here. We have two basins around India and in the southern hemisphere. Right? So this is where the areas that are more exposed to this. You can imagine, before we go here, see all the expensive properties that is usually across these areas, right? Very expensive properties. And for insurance, so this is a high risk. So why do they occur on those areas? One of the main predictors here are the sea surface temperature. There is warm air. The warm air with the wind evaporates, and that evaporation triggers an instability in the atmosphere. That's the fuel. This is the warm ocean, warm water. Sorry, this is a map of the sea surface temperature. So the warm water, as it evaporates, releases energy and creates instability in the atmosphere. Instability means ascending motion, right? And so this is the main ingredient. And if we want to train a machine learning model, an artificial intelligence model to predict the seasonality of hurricanes, this is a variable that we would put in there, right? Some sea surface temperature in different parts of the ocean. Other things that we see that can be good predictors for our machine learning algorithms with the knowledge, because this is better if we could do that based on physical understanding, right? For finding the features. You can see, for example, when there are winds, a cold front that moves around, right? And then in there, it can generate instability. Also, there is cyclonic rotation that is usually generated over this coast of Africa, and when it goes into the ocean, it creates a big cyclonic rotation, big storm. Another area where we see this happening is the wind converge in the equator, right? And the equator, we call that the intertropical convergence zone in meteorology, right? So there is areas where you have convergence, there has to ascend. And there are waves, tropical waves or easterly waves, that these are a belt around the planet, and every 5 days you will see on the same spot a wave happening around. So they go in a train around the planet. These are areas where you see, imagine a human that is looking for those things with their eyes and say, oh, this is an area of development. Now imagine an artificial intelligence system that can do that. Right? This is an opportunity here. You see patterns, computer vision that look at patterns and then say, okay, this is a potential for the development of a tropical cyclone. For us and for communication, us humans and for communication with the rest of the public, we usually categorize the hurricanes into five stages based on the severity of the winds, right? And if it is below 74 miles per hour, then we have something that is tropical storm. It's going to have its own name because there is still a lot of damage that this can cause. And if not, we call that a tropical depression if it is below 38 miles per hour or 70 meters per second. And so insurance, for example, can be categorized based on this, because this is what the government or the officials are going to tell us. Okay, this storm is a category 2 or a category 4. And so I can insure my property or calculate my risk based on this. What is the risk? For example, we can say, what is the risk of having a storm that is larger than category 1, right? And if I see a high risk, I try to diminish that risk by buying some protection product. So the hurricanes are also very close to me, as they are personal to me, because I worked before as a weather forecaster, as a meteorologist. I had the opportunity to be visiting meteorologist at the National Hurricane Center, and I had the opportunity to fly into one of these aircrafts that are hurricane hunters. So this is me many years ago, and so this is quite an experience. And so you can see you can realize that a hurricane is more than a data point. It's a structure that has many dimensions. It can go up into the atmosphere, right? And then you are going to have circulations that go up and around and then on the other direction. And that creates hazard for not only for the people at ground, but people, aircraft, for example, and other structures, other assets that may be in the vertical. So you will see also an area that is very calm at the center, is where the air descends, right? And so the clouds cannot form there. It's very calm, but it's the calm after the storm. And this is in here, the walls is where you get most of the damage. These are pictures I took for Hurricane Floyd. Hurricane Floyd at the time was the largest evacuation in the United States. Right? So people all across the Atlantic coast were evacuating because the hurricane was passing very close to that. And so what you can see here, this is looking back, you can see more or less the rotation of the clouds. The ocean is below these clouds. These are very low level clouds. And then there is a wall that goes up, and then blue skies. Right? This is a part of the wind also. And you can see the contrast of blue skies, very calm. Once the aircraft goes into the wall, it's going to have a lot of turbulence, very heavy turbulence. Okay, so this is an anecdote. Now let's go back to the data. So what would you think would be the worst hazard that we get from tornadoes? To answer that question, and you can still think on that, but to answer that question, we can see data that are based on papers from Rappaport in 2014, where he did an estimate, and we see that storm surge is the worst of the hazards associated with tropical cyclones. We even get other hazards, rain and flood associated with that. We get tornadoes inside the hurricane, right? So this is another hazard. Right? But storm surge is the worst of all. And see, this is what storm surge look in real world, not only in data, but in the real world. This is in Texas after Hurricane Ike passed by, right? So you get the storm surge, right? So the storm surge, as the hurricane passed by, the hurricane is a low system pressure. It's like a stroke. When you suck the liquid ascends. So it's the same. The hurricane is going to suck a little bit, reduce the pressure, the ocean ascends. And there is going to be drag of water around because the hurricane has rotation, has winds. And as it approaches into the land, there is going to be an addition of on the column of water, right? So you are going to get a lot of water above the sea, what is usually the sea level. That's a storm surge. And because there is a circulation, you are going to have larger risks on the right side. I see, for example, here, this is a hurricane, a theoretical hurricane approaching Miami, right? And so what you get in here is all the greatest storm surge in here, because you have all the push of the air in addition to the other two components, which is the low pressure and which is the bathymetry, or the ground topography underwater that we get, right? That is going to create an extra elevation in the water. So as you can see here, I also had the opportunity to work here. Here is me in the National Hurricane Center, right? And so what I'm going to show here are some examples of how this is forecast by meteorologists, right? And these are the maps that we see to see the risk in the shorter term. For example, here is one storm in particular, right? And then you are going to have a storm, tropical storm, then a hurricane, and there is an area of influence, the cone of influence, because there is an uncertainty in the prediction. The center can go either way. But remember, usually to the right is going to be a lot of risk, a lot of wind and flood. The winds are going to be stronger to the right. So it's not symmetric. What is symmetric is the distance with respect to the center, not necessarily the damage. And then there are humans that estimate this, and then they create warnings and watches, right? So warnings and watches. We're getting here. This is an important concept, and it's not consistent. As we get more data, we can correct the cone of influence. This is another example in here, and we can see how the spread becomes larger, and we can see here a warning that is put here for hurricane storm winds and for tropical storm winds. Okay, for a particular case. So these are the type of maps that exist nowadays for us to estimate risk. And this is another example, right? Watch and warning. So we were saying there are watches and warnings. Watch is a possible cyclone threat, and a warning is conditions are expected. The certainty is much larger in a warning, right? We are expecting this to happen within 36 hours or less, right? Well, a watch is a good chance, 48 hours. Watch out for it. It can happen. And based on that, then there is an area based on the uncertainty that is going to be warned. Again, here we're estimating risk in terms of short term, right? And we can automate a lot of that based on the errors that we have based on the forecast through time, right? So this is in the 60s to 2010, the error has been reduced in these predictions, and the forecasting period has been extended, right? So if we want to train a machine learning algorithm, it's better that we focus on certain periods, right? We cannot take the entire time series to train this, because you see that the skill has been changed. There is a shift in the data that we use as a target in here, and so this is important to consider. This is intensity. The intensity. If we want to build a model, machine learning model that predicts the intensity of a tropical cyclone, again, there has been a shift in the target variable, the feature the variable that we want to predict, right? In the 70s, for example, the error were higher than they are nowadays, and we can go larger in time. So with all this consideration, I ask, what do you expect for the hurricane season this year, especially in the Atlantic? So let me ask that question, right? So first, things that we know, the names are easy to know, because they are selected by a committee by United Nations World Meteorological Organization. So there is a package of names. These are the package from last year and the package for this year and 23, etc. And so the names from 2021, some of these names are going to be removed because they cause a lot of damage, right? but the ones that remains are going to put back here in 2026. Right, and so this is how it works. And there are also supplemental names. There are seasons where we get a lot of tropical cyclones, more than these ones. We run out of letters of the alphabet. You see A, B, C, D, E, F, G, etc. And male, female, male, female. So this is how they put the names. Sometimes we run out. So we need to use the Greek alphabet to do that. So we know that this is to expect next year. There are predictions of how many hurricanes we will going to have, how many named-storms, how many major hurricanes we're going to have. And one of the most prestigious forecasts are done by Colorado State University. Since the 1980s, they have been doing this, and this is a regression algorithm, right? And so for this year, they expect to have 19, while the average from 1991 to 2020 is way smaller than that. So we expect to have a very active tropical cyclone, tropical storm, Atlantic hurricane season for the current year. That is the season start in June. Okay, so this one we can also do a machine learning algorithm using algorithms like Ridge, Lasso, and Elastic Net based on predictors, and the predictors are usually something that we call teleconnections, like El Nino, La Nina. Right? These are patterns in the sea surface temperature that we were mentioning before. So we can put that as features into the model, and we can create these predictions with particularities for what we want to, for our product or for our properties or for our services. So in here, I like to pause again. So while we dive into the business applications of the talk. Moody, is there anything present that we have, like questions or comments from the audience?
Yes. Hi, Edwin. So there are questions. If you want, we can pick them now, or we can pick them towards the end as well. What's your preference? So we can probably. So, what's your preference, Edwin? I'll ask you.
Well, I can address one or two, and then we continue with more on the presentation.
Sure, sure. So I'm picking one of the questions that Jordan has asked. So I think there was a data that you presented around hurricanes, which is where Jordan has asked this particular question. Yeah. Can you answer this one? So
Have
how? Yeah.
hurricanes been getting larger or just more frequent, right? So the size, there has not, I haven't read of evidence that with climate change, the size have changed, right? So the frequency also has changes that are not necessarily associated with climate change. What we are observing is that they are becoming more energetic, right? So the energy is measured by the strength of the wind, right? And as they become more energetic, right, they can create more damage, and our risks are increasing, right? So more frequency is still unclear because there are patterns. Like every 10 years we get a spike, right? And there are other seasonalities in there. So we are still debating. So the frequency of hurricanes associated with tropical cyclones, this is still an open question. What we can answer is not necessarily being larger or frequent, but being more energetic, generate more damage. Did that address the question? Good.
Yeah, I think Jordan can answer that over chat. Meanwhile, we'll pick up another question. I think, but I think thank you very much for that elaborate answer. It's an interesting question that Tanu is how we pronounce it. I'm so sorry. Are these ML problems related to climate, and are these mostly supervised or unsupervised learning problems? And how much label data we have in case of climate problems targeted by MLAI?
Mhm. Yeah, I will argue that these are mostly supervised problems, right? We are based on time series. This is what is happening. We are based on patterns that humans have already created maps, right? Weather maps, for example, right? And so we can now train machine learning algorithm based on a satellite image where some things are happening based on weather maps that the humans are doing. And so most of those, in summary, are supervised.
Okay, okay. There's an interesting question that Desta has asked. These names are very confusing. How is the nomenclature made?
So the nomenclature. So there are committees by the United Nations World Meteorological Organization that create this list of names of storms. And so the list that I show here is for the North Atlantic. Some other parts of the world have their own committees, and they put it, and they want to be mindful of genre, for example, discrepancies. So some name is going to be male, the other one is going to be female, male, female, and they are going to follow the alphabetic order. So this is how the names are doing. Now it's not based on speed or damage they cause. The speed or the damage is going to be given by the category. For example, a hurricane with a given name can go through category 1, 2, 3, 4, 5, right? At different times on the time series because they are at different speeds.
Okay, okay. Thanks for that answer. And Jordan and Nathanus have also conveyed the thank you to you. I thought I must pass it on for sure. There's a question that I want to. So there are certain questions that I have, about your data science journey in the climate risk space. But I think I'll pick one from Satish, if first, because so he's asking, do we have any public repositories to access climate data
Mm-hmm.
for training supervised risk quantification models?
Yes, and I can share some after the talk. Yeah, there is a ton of data. We were seeing the millions of observations per day, and these are all paid with our taxes. So the weather services usually in your country are going to be the best resource to find those data. But I can post some links after the talk, and maybe that's a good time to continue with the last part of the presentation, and we can
Yeah, yeah,
address
sure,
the
sure,
next questions after.
sure. Over to you.
Excellent. Okay. So let me go back to the slides. And here what we want to go is over some business applications. Okay, so let me see where. All right. So use cases. Let's focus a little bit again on insurance, reinsurance, and how they calculate the risk and what the opportunities exist in there. Okay? So usually, what we are going to have here for hurricanes, you have data from the track of a tropical cyclone, right? So you calculate the intensity of that footprint, and you estimate the damage to a particular asset, a particular building or property uh, that has been damaged by that tropical cyclone or like that hazard. Then you calculate the loss based on wind, right? So now this is what the industry has been doing for a while. So you put now, and if you can see here, for example, this is a sigmoid function which we use in machine learning a lot, right? So there is one thing here that we can do with machine learning, right? Based on the data, these are the winds are going to be the target variable, and you can have the number of claims and the average price of the claim, right? And you can create sigmoid functions based on that just by using machine learning. And this is inspired on what the industry is doing right nowadays. Now they have models nowadays to compute the risk and that we have, right? So these are huge models, right? You are going to have input databases like land cover, storm tracks, the construction type, the terrain, the type of terrain, the elevation of the terrain, and then you are going to put on top of that a wind model, right? So let's see, if you have this type of storm with this category, the wind is going to have these shapes, right? And it's going to have in 3 dimensions and plus time, right? So this is going to be one model on top of another model. Now you are going to have another model on top of that that is going to multiply this wind in 3 dimensions by a factor that and land cover and the upwind terrain or downwind terrain, and those things are going to be feeding a damage function, right? See, this is like a sigmoid function that we were seeing in here, and this is going to give us the losses, right? The fragility of the infrastructure to be damaged, and based on that, you feed also the value of the property, and then based on that, you get the damage. And you run this many times, and now you get a frequency model, right? How much that damage you have to pay over time based on certain type of storm, right? And if you want to consider the effect of climate change, you run this based on a scenario that is going to happen in 50 years or 100 years. And to run that, you need really big computers. And to run that, you need a very expensive model. There are companies that sell those models, and they get large profits because the price is expensive, right? So let me see what we can do in here to simplify things. For example, we can improve the damage function in here. And so this is something that I did when I was working at the Argonne National Laboratory for the U.S. Department of Energy. So Hurricane Sandy was one of the costliest ones because it affected a very populated area here around New York. Right? Hurricane Sandy affected infrastructure, right? So electric power substations that are flooded are not good for the distribution of electricity, right? So usually through machine learning, we were able to have a system that is going to allow us to calculate risks in half an hour instead of what we have before, that where we have 2 or 3 human analysts spending 2 or 3 days to produce those maps. Those maps are important because they go to the Department of Energy when every time there is a hurricane, right? And so they can make the decisions based on that. So this is what we did. For example, here, this is the impact of the wind, right, for Hurricane Ivan on the electric grid. And the maps of the electric grid are very sensitive data, right? So they are kind of secret data. So what we did here, we have an artificial electric grid with some, each point is a different condition on the assets, right? Different parts. But this is an electric grid that is synthetic, it's artificial, it's fake. But they give us that, the government gives us that map so that we can, when we give them the model, they just shift the map and they put a real map of the electric grid, and now they have the assets. And we have each of these infrastructures, right? They're going to have a failure curve, which is what we have here, the probability of failure. You remember the Sigmoid function from machine learning, right? So this is what we use here. And then there is going to be a function here that is going to depend on the wind speed, right? And for each of these points, we are going to get a real time or a function of time, whether or not a response, whether or not there is going to be a failure in the infrastructure. So here we see here the control run, and then we see here the sensitivity analysis, right, for the hurricane. If the hurricane goes beyond certain value, which part of the electric grid is going to be damaged, right? And this can be properties or some parts of the distribution of some product that you have. The supply chain, for example, can be used in here to simulate what is the effect of the supply chain, what is the effect of the hurricane on the supply chain. Right. Okay, so this is one example. Another example that I want to go over is parametric contracts. So right now it's very cumbersome for somebody to have an insurance for hurricanes, for example. You go and then your risk is calculated, right? It takes some time, but then let's say you get the damage, the hurricanes pass near you. It can take 3 months to 1 year and a half to get the money back, right? And there is a ton of paperwork that has to be done. You need people to go and prove that there is damage, and you need to provide also evidence that there is damage. And you're not going to get all the money back, right? And all this while you are during the stress of what to do, right? My house or my property has been damaged, and I cannot continue my business, or my personal life is being disrupted. So my colleagues at Parachute, they are reimagining this, how to proceed on those cases. What if instead of centering on an insurance product, which are based on estimate of damage, you saw how complicated was the model that insurance industry uses. How about if we have a different product? Let's not call it insurance. It's something else that is centered on the exposure of the natural hazard. The natural hazard, the hurricane passed at a certain distance from where I am. So this can be trigger automatically for a payment that I'm going to receive because it was very, very close. Right. So now, in that case, our colleagues at Parachute, instead of having a very complicated model, it's very simple. At the end, you get the input databases, historical storm tracks. You get machine learning that is going to learn frequency, right, and the expected losses for a particular year based on the storm tracks and based on the current teleconnection that we have for this year. Right, so it's the traditional models that we have in insurance is going to give you the risk for any given year, the risk of a tropical cyclone for any given year. This new paradigm is going to give you the risk of a hurricane or a tropical storm for a particular year, the year in which you are. Right, and that makes more sense to me because usually you buy insurance for 1 year or for a few months, and nowadays people are buying for an event, a wedding, or a trip that they are doing. Right? So these are very short terms. You don't need to consider all the what is going to happen due to climate change. You can focus on teleconnection and other features that can be more predictable in these time frames. Simpler is better, that's what I say. So based on this data set, and then they also have proprietary algorithms that use scene image processing and computer imaging. Those algorithms are applied here to create a map of the risks, right? You can see the areas that are more riskier for a particular type of tropical cyclone. So let's see, these are very high resolution maps for the risk for one hurricane within 75 miles of location, right? And you can change that, and the color is going to change, and the pattern are going to change based on the type of storm that you look. You can look for, you can insure for a hurricane category 3 or category 4, and it can be 40 miles or 20 miles, right? So it depends. And you can also, this is something they are working on, reduce the time frame. Instead of having for an entire year, you can, how about if you buy this product, this protection, this reduction of your risk for a month only or for an event only. So this is very exciting. Then on the other side, how about if you are affected, right? So right away, these are synthetic data experiments that were run for last year. This is for Hurricane Elsa in 2021. Let's say that there are 100 policies in Florida. And so on real time, depending on the type of policies, some of those are going to be triggered. Like in here, we have 3 policies triggered right away. The line in here is the track of the hurricane. Dotted line, tropical storm, line, hurricane. And each point in here that you see is the center of the hurricane. Every certain number of hours, the National Hurricane Center is going to give us, in Miami, is going to give us a position of the storm. And we can interpolate in that, and then we can calculate distances. And this is all done on real time by Parachute. So this is amazing. And so once you get that, these 3 are triggered, and then you get another map, for example, in here, with different type. This is for another hurricane, Michael, in 2018, right? So, but you can see, okay, these ones are being activated. Let's trigger a payment, right? And now there is where the human in the loop comes. Okay, they confirm and they say, okay, the payment can be sent now to these people, and that takes only a few hours instead of the 3 months to 1 year and a half, because there is a lot of automation, a lot of AI embedded into the service. Another thing that is possible nowadays with machine learning is to test business models, right? So with hypothetical products. This is one of many tests that were done at Parachute. For example, the profit of my business is going to be based on what the cost of the product, the protection product against hurricanes cost. The client pays this. An investment incurred loss. This is usually what is, and plus expenses. This is the traditional business model of insurance, right? So in here, what we are going to have is the premium, the expenses, and something in between that can be a variable, right? We can change that. And now the model is going to affect the hurricane model. The hurricane risk model is going to affect the earned premium, right? So let's say we have a particular earned premium, and now we run it through the time, and we get what is the loss ratio, right? And we can also differentiate by particular states and find which states are going to be more risky, which ones could be more profitable. Mhm. And so in that way, you can test different business models before you go to market, right? And all using this could be model as a multivariate regression, rich lasso, trained with the profit. You don't you can assume a profit, right? So this is going to be your target, and the other one are going to be the model features. And so for this particular run is 31%, but you create many runs, and now you decide how to go to market based on these business model tests. The app. So always people ask for an app. So it will be great, so great if you can have the product and say, hurricane risk. I want to reduce my hurricane risk. So I just move the app to the left, and it give me a product, and it's going to tell me, okay, it will cost you that much. And then you make your decision. So this is another product that Parachute is working. So and it is all secured by the blockchain smart contracts, right? So this is the future. It's very close, right? Very close to us, and a lot of opportunities. So I'm very excited to what is coming on in the field. And now at this moment, I'd like to welcome your questions, additional questions or answers. Mhm. Back to you, Mudit. Okay, so I'm going to see if there are comments or questions. So I'll take the most recent one. Is the classical machine learning model simpler? Okay, there you are.
Yes, I'm so sorry. My internet was being very nasty recently. Thank you so much. Yeah, I think yeah, sure. Go ahead. I think you were picking this question around. Okay, I think we can start off with this question by Atanu
Mhm,
again. Yeah. So in practice, is the classical ML
mhm,
models
mhm,
are they better in terms of prediction performance, or is it
mhm.
deep learning based models for climate risk?
So the advantage of machine learning models, which you call it here simpler, is that there is an intuition that you can see right away. Okay, these are my predictors, uh-huh. And they are based on physics, right? So you usually can pick it based on your knowledge of the physics of the atmosphere. And if there is regulation, you usually have to explain, okay, why you make your decision based on this. There are more and more regulations happening around AI these days around the world. And so you should be able to have models that are explainable. And this is challenging if you use deep learning. Also, deep learning requires large data sets, large time series. And as you see, the climate is getting warmer. So there is a lot of shift in the time series. And so you have to restrict your training set to smaller periods. And that's a challenge for deep learning.
Okay, okay. Thank you for that answer. Um, Also, a shameless plug here. We have a bootcamp going on in explainable AI. So if somebody wants to learn, they can join in. But yeah, I think we can go to next question. Okay, so this is something that Maria had asked, and a few other users have also asked. Is basically if somebody wants to get started in terms of learning, taking this forward in terms of learning about climate change and application of data science and climate change. So, what resources would you recommend to them?
Mhm. Yeah, the American Meteorological Society has one course usually every year during their annual meeting. Right? So this is one, and because of the pandemic, they have been doing a lot of events online. There are also a journal by the American Meteorological Society on AI. Right? So it started this year. It's quite new, so we can get articles out of that. So these are two things. It's quite new. There is a lot of effervescence, new things coming up. So perhaps one of these days we will see one in DPI in this community. Mhm. But so far, these are the two resources that I can recommend.
Okay, okay, thank you. Um, one question that a community member has asked is, okay, this is, by the way, we've crossed 1 hour, so you can absolutely feel free to I think this can be the last question, or if you have time we can pick more questions. It's totally based on your convenience. um, there's one question that Satish has asked. Is basically, does Bayesian analysis help in making better risk prediction by accounting for uncertainty in the climate data?
Mhm. Yeah, no. First of all, thank you for all the interest and all these questions. I can entertain a couple more questions, and then the rest by email or a direct message. For this particular question, the answer is yes. If you have a knowledge, a prior knowledge of what to expect, you can adjust. And I was hinting towards that when I was saying, okay, we have a map of the risk of hurricanes for any given year. But for this year in particular, we expect an increase in these numbers, right? By Colorado State University, for example, or many others that we can do. So now we can create Bayesian analysis here to reduce or the uncertainty of the risk. So totally, Satish, thanks for the question. Agree? Yes.
Thank you for that answer, Edwin. I have one question that Alan has asked on YouTube. So he's one of our active community members. He's asking, is there any research on prediction of analysis of, again, around climate risk, but some other type, like something around earthquakes or something of those sorts?
Yes, there is, and the short answer is very difficult in the short term. Right? So what exists is in the long term. For example, you can see maps of earthquakes, how they are happening over certain areas, right? And usually tectonic plates where you have a certain type of tectonic plates. You can see the frequency that happening there, and on top of that, you see, okay, when was the last time that there was an earthquake along this area of the tectonic plate? Right? And so you see a lot of here, but there is an area of the tectonic plate where you haven't seen much earthquakes. There hasn't been much release of energy. So there is something about to happen in there. Right? So in the long term, you can use those techniques, right, to see what to expect on the long term, 10 years, for example, 5 years, 20 years. But on the short term, it's very difficult. I don't think the community has been able to find something usable.
Okay. Okay. I think one of the community members, William, has asked where can they ask questions. So I think they can ask it in the comment section itself. They have joined via LinkedIn, I guess, but yeah, you can ask questions, and we're having a look at it. So yeah, please feel free to do that. One more question that I was very curious to know, and it's something that we got from a couple of community members, is basically, I'll just pick that one. We received that from around 3-4 people actually. So, technically, if you look at this area of climate risk and applying data science into it, so where does your personal journey start from, and where do you think this is going forward? I mean, in terms of applying AI into climate risk, what do you think is the one of the biggest trends in terms of business applications if you're looking at this particular space as a whole?
Mm-hmm. Yeah, some of the regulation that is happening these days, right? In terms of, okay, now the business have to report their climate risks. So I think this is where our opportunity are. And again, it has to be explainable AI. So that is going to reduce the type of algorithms that we can use. Traditional machine learning algorithms seems to have a large adoption because they are easy to explain. And also in the finance sector, if you can create metrics, right, scores, right, that go over large amounts of data, and then can pinpoint certain locations. For example, let's say I'm looking for a property to invest in a property, and I noticed that properties for apartments near universities seems to be very robust during the pandemic for a particular country. Right? So can I train an algorithm that are going to put that into consideration in geospatially, and also that is going to find, okay, I want to be weighted in there in my decision, something about the climate risk, right? So there is a lot of rules that you create in that, and that's your training set. And now you have the same patterns, and you ask a machine learning algorithm to compete with respect to what the human did. So all these competitions of what the human does is the baseline, and what machine learning can do right? And adding value to that. That's where I see a lot of opportunity these days.
Okay, okay. Yeah, I think okay. One last question that I want to pick is okay. I think we have clearly overshot. So I would really want to respect your time here. But this is one question that I want to pick towards the end. Is I mean, this is reflection on domain expert knowledge to apply ML models and their interpretation. So yeah, if you can probably answer this
Uh,
one.
so that's fundamental. Thank you, Desta. So on Heyman, for example, the practice that I have at Heyman, we have subject matter experts and we have data scientists, and we meet one or twice a week to evaluate the model. Right. So they have a lot of intuition where the best data are, what the best features can be for a model, and we, as a data scientist, we get that expertise. We generate our models and feedback to them, and together we analyze the behavior of the model and refine many ways. And at the end, these experts, subject matter experts, are going to be the best stakeholders. That they are going to help add adoption into the models that we use and that we deploy. The worst thing that could happen is that you have the most beautiful, best constructed machine learning model, AI model, you deploy it and nobody uses. Right? So we need these experts that are going to be our advocates.
Okay, okay. Thanks for answering that for Desta and other community members. One last question that I want to pick is William had been looking to ask this question, so I'll pick this one before we wrap it up. If you could kindly answer it. So, uh, okay, this is very specific, but yeah, aircraft-based observation ABO, such as AMDAR and humidity reporting, can improve models in a valuable way. Uh, Okay, is that possible?
Mhm.
Is probably what he's asking. And if yeah, if more such data samples were sent or streamed from aircraft.
Thank you, William. So just to acknowledge, William and I, we used to work before and a startup called Uptake. So it's great to see you here. Thank you for the questions, very really relevant as well. And the answer is yes. So one of the examples that I see here is on application, actually business application of AMDAR. So AMDAR and humidity reporting. These are sensors in aircrafts, and then they share it or they to the community, right, to the aviation community, and even to the weather community. It's challenging for the operational weather forecasting models to absorb that because, like, again, they have to pass through a certain number of tests so that the assimilation of those data are not going to affect their model performance, right? But also there are things that can happen at the airport level, right? For example, let's say icing. Icing is very expensive to manage, right? You put a certain liquids on the aircraft before icing, right? But if you have and you assume that there are certain conditions above the airport. Now, if you have these sensors on the aircraft and there is aircraft constantly coming up and down, you have a real-time monitoring of what are the conditions above the airport, right? And if there is icing condition on the airport, I can act on the ground to protect the aircraft, or I can not waste a lot of that expensive fluid in the aircraft if now the conditions are changing. So I've seen a tremendous opportunity of using AMDAR and humidity reporting to minimize the risk of things like icing. I hope that answered your question, William. Moody,
Yeah, I
your
think William would respond via comments. Please let us know if this was addressing your question. But thank you so much. I think you have been very kind enough to first of all prepare this absolutely detailed presentation on the topic and then answer the questions across various domains. So I think we have already passed the 1 hour bar. So and you're open to taking more questions. So thank you very much for that. One thing that I want to pick up is yeah. So Desta has pointed out that this session is very crucial, in particular for US, since we're still experiencing wildfire disaster in Arizona and California. Yeah, I think that's a very important point, and it's as I think what you mentioned, right? So while it has a massive impact on the business front, something to the tune of thousands of billions of dollars. I was actually surprised to see those numbers, but at the same time, there's a lot of risk to life involved in the process. And I think yeah, as we as a data science community, if we can make it better. So we'll be looking forward to a much better world thereby. And William says thanks, by the way, so I want to pick that up as the last note. So thank you very much, from William, from every community member who have joined in today. Thank you very much, Dr. Edwin, for joining us. I would recommend everyone to check out his LinkedIn. We have been tagging him in all the posts, so follow him. Do go ahead and do that. And yeah, and if he has any resources to share, then we'll be happy to email you to them. Email those to you. Yeah. Okay.
Thank you all for having me. It's been a tremendous time, and see a lot of names of former colleagues of mine. Thank you, Murid.
Oh, interesting. Thank you. Thank you,